Good afternoon and welcome everyone to today's ARPAS-UK CPD session on fuel cell power systems for commercial UAS. These ARPAS-UK CPD and future-facing sessions are designed to improve everybody's knowledge of what's happening, what's available, and where the systems may go. We aim these at both the end users of industry, so that might be within the construction industry, it might be within very much the sort of the future element of the UK drone industry. We're always very happy for members to get in touch with us to arrange to host a CPD session themselves on a relevant topic. We are delighted today to welcome Andy Kelly from Intelligent Energy to talk about fuel cell power systems for commercial UAS. Andy is responsible for the Intelligent Energy SAW products, the fuel cell power products for UAVs. Andy's held product design roles in the green energy market for 14 years, so he's extremely knowledgeable, with a focus on fuel cell powered drones for the past 7. His expertise lies in bringing new, complex technologies to the market and user-friendly, scalable products. Andy is experienced in product legislation and certification, and during his time with Intelligent Energy, he has been involved with and led the CE certification process for multiple fuel cell products. Andy's main career goal is the success of the IE SAW line of fuel cells. So, Andy, I'm going to hand over to you now, and looking forward to learning them myself as well. Thank you.
Thank you. Thank you for the introduction. So just to slightly expand on that a tiny bit, the IE SAW range of products is Intelligent Energy's product line that's focused on UAVs. So they're fuel cells that are lightweight, targeted at increasing flight time for UAV operators. I'm going to talk about a few things today. These are kind of the headline advantages of fuel cells for commercial UAVs. But what I'll delve into in a little bit more detail are some of the technical features of a fuel cell and how they compare to batteries, how you might have to think about things differently, some of the commercial and operational benefits, comparisons between fuel cells and the competing technologies, batteries and IC engines, some key applications where fuel cells make sense, examples of some of the integrations that we've done and that our customers have done and our close partners have done, what they're used for. A little bit about getting hold of hydrogen, the different refueling options that there are, regulatory update, and then an opportunity for you all to ask questions. I'm sure I won't cover everything, but happy to take questions at the end or after the presentation. So just in front of us there, the main reason fuel cells for UAVs exist, the main reason they make sense is they can increase the range of UAVs. This leads to increased operational efficiency. It enables applications that weren't previously possible. BV loss, you guys will obviously have heard lots about BV loss flight. Range is a key aspect of BV loss flight, and fuel cells enable that range. Fuel cells reduce total cost of ownership. I'll cover that in a later slide. But yeah, the headline is significantly longer flight times. I'm going to go first into a couple of basics about fuel cells. I won't spend too much time on this. Not everyone will find it super interesting, but just so you guys can kind of know what I'm talking about and know why the fuel cells exist and how they work at a high level. Effectively, the products that we sell are a battery replacement product. The idea is you take the battery out of or off your current UAV and replace it with a fuel cell, and it provides the power to your UAV. It is a UAV power component. The fuel cell itself, it generates electrical energy. It's different to a battery in that it doesn't store energy. It generates it. It converts hydrogen into electrical energy. So that's the main difference at a chemical level based on how it works. And the reason you get this extra flight time is that hydrogen is more energy dense than battery technology. So there is a lot more energy in a given weight of hydrogen than there is a lithium battery. The reaction itself is clean. The only output there is the electrical energy and water. And the way that you refuel a fuel cell system, you just have to put more hydrogen into the fuel container. You don't have to recharge it like a battery that might take a few hours to recharge. You just have to provide more hydrogen. As long as the fuel cell is being provided with hydrogen, it will provide electrical power. So there's a couple of key differences for an integrator or an operator to know about. That a slightly different way of thinking is required, whereas with a battery, you are used to thinking of a battery of having a discharge rate, which is the power output rating effectively, and a capacity, so the amount of energy that's in the battery. With the battery technology, this is all just inside the battery, but with fuel cell technology, those things are separate. The power, the discharge rate is determined by the fuel cell module itself, and the capacity, the energy, how long it will run for, is determined by the cylinder, the hydrogen storage component of the system. And like I mentioned before, if you add up the mass of a battery, say if you had 1 kilograms worth of battery, and if you had 1 kilograms worth of fuel cell and the hydrogen storage, then you're going to be carrying a lot more energy on board, so you can fly for a lot longer. But it's just a slightly different way of thinking about how capacity and discharge rates work. Another thing worth mentioning about our systems, I'm not, like I said, I'm not going to spend too much longer on the technical stuff. We'll get into some exciting stuff shortly about what the main advantages are, but just so you understand how these systems work. Peak power and battery hybridization. So I have to admit, batteries are really good at some things. Batteries have got great power density. Fuel cells have got great energy density. And the way our systems are designed, it's best of both worlds. So we hybridize a fuel cell with a small hybrid battery, and you get quite a lot of advantages doing that. You get a really optimized system. What this chart is showing here is kind of the load profile over time of a typical sort of rotary wing UAV. And you see the peaks there might be when you're accelerating or climbing or stabilizing, something like that. Our systems are designed so that the fuel cell will put out a constant amount of load, and the small hybrid battery will take the peak load and be recharged when you're in a trough, if you like, on this chart. What that means is you don't have to size the fuel cell for peak power. You have a much smaller fuel cell and a much smaller battery working together. You get a really optimized system for both flight time and discharge rate and load response. The other key advantage that this gives is you have power system redundancy as part of the circuit. These hybrid batteries can be in place to also act as emergency flight time. So if you were to run out of fuel, or if there were to be some kind of error with the fuel cell, it's very rare. It's obviously not what we aim for, but if any of the power systems are to fail, you've always got another one there providing load to the propulsion system. So there's a couple of advantages there of having this hybridized architecture. So some of the benefits of fuel cells for UAV market, that typically our products are aimed at commercial fuel cell users. The headline I've already mentioned is much more flight time. It increases range, it increases your time in the air. That's good for efficiency. Improved total cost of ownership. So I'll cover that on the next slide, go into a bit more detail on that. The product itself runs almost silently. There are zero emissions. So when you're comparing to something like an IC engine, which might have a comparable range, the vibration, the noise, the emissions, we're really winning in those areas. And operational efficiency and refueling. So you might spend hours charging a battery, or at least prepping to leave a battery on charge. Fuel cells can be refueled in minutes from 0 to full. So you've got a much better operational efficiency from that point of view. Also, you're spending much more time in the air. You can cover more distance. Operations can be transformed because of that extra range. Excuse me a second. Some of the key technical benefits. So the way these systems are designed, they're designed to be a direct battery replacement. You don't really have to know anything about fuel cells to implement one of these systems. The UAV will not know any different. The fuel cell system follows load just like a battery does. The safety and reliability that's gone into the design of these products, they're fully single point failure tolerant, the built-in power system redundancy that I've already mentioned. Systems are modular. So we have two core products that we offer, 800 watt and 2.4 kilowatt systems, but you can combine these in parallel, up to 8 systems in parallel for much larger payloads, much larger UAV systems. And much reduced mechanical maintenance and risk of mechanical failure. So if you're comparing this to, again, the comparable range of an IC engine, the difference is you don't have to do that really frequent engine overhaul, that rebuild. This has no moving parts apart from a cooling fan. So the maintenance regimes required are almost zero. Another thing worth mentioning as part of the technical benefits there, the interfaces of our system were integrated off the shelf with the Ardu Pilot flight controller software. The outputs of the system are a very simple serial UART or CAN bus connection, and that communicates all the key information like remaining fuel, a very accurate fuel level reading, in fact, whereas with a battery, you kind of have to just rely on the voltage, which can be unpredictable depending on the age of the battery and things. With the fuel cell, you're measuring how much pressure is in a cylinder, so you know exactly how much fuel you have left and exactly how much flight time you have left. Hopefully those benefits make sense to you people that are listening. So I'm just going to move on here. We've got a couple of examples of multi-rotor UAVs. This slide kind of shows the endurance comparison of a couple of example systems built around our fuel cells, and these aren't special UAVs by any way. These are standard off-the-shelf components, really typical commercial UAV components and sizes and payloads. But what you can see on this chart, the blue lines are the fuel cell UAVs, the grey lines are the battery equivalent, and you can see as you go up the payload axis how much flight time you're getting on these platforms. These are real world, real numbers. These are tested. We've built these, we've run them. This is some of the platforms we use for testing here at IE's head office. But like a couple of points that I'll pick out on the chart: 5 kilos for 120 minutes, 7 kilos for 90 minutes. On the larger UAV, that's aimed at a 25 kilogram all at mass. For obvious reasons, it's an obvious regulatory sweet spot there. On the smaller UAV, you've got a kilo for an hour for those that are wanting a smaller package. But hopefully this kind of shows on a very specific working UAV platform the advantages that you're going to get. I promised I'd talk about the total cost of ownership of the fuel cells. So, yeah, there's no getting away from it. I'm sure everyone thinks hydrogen fuel cell, new product, that's going to be really expensive. Well, initial capex, initial outlay is more expensive than a battery system, but over life they are much cheaper. There are a number of reasons. So the product lifetime is average of our system 2,000 operating hours. That's without any maintenance or anything. They will last for 2,000 hours. Upwards of that if you treat them nicely. The battery equivalent, and we're talking the kind of top of the range or at least industry standard battery packs that would be used on this kind of platform, you're going to need over 80 individual packs to run for that many hours. So although the initial capex might be higher over the life of the product, it's much cheaper. At volume, we reckon will be half the cost of batteries at least. Additionally to that, the amount of time you spend charging, so the OPEX is hours versus minutes. Hours of time spent managing batteries, but minutes refilling and managing fuel cells. Not least, you can see in that picture, think of the waste, the environmental waste that you would get, the equivalent one of these systems versus 80 battery packs. Our system can be recycled, the battery packs not so well. So it's worth bearing that in mind as well. Moving on, I mentioned that I would talk about the advantages versus competing technologies, a little bit of a comparison. So versus IC engines, where you do get a comparable range, comparable flight time. Fuel cells are clean, zero emissions, operation is nearly silent, really low noise signature, also vibration, low vibration because of no moving parts, which also reduces the maintenance. There's no tuning required for different environmental conditions. So I think some of the advantages clear there. Compared to batteries, the obvious one is the increased energy density, meaning you get much increased flight time, the built-in power system redundancy, and much quicker refueling. Some common themes there that I've mentioned already. I'm not going to go through the whole of this comparative chart, but it's a good one for reference, for information, like kind of a direct matrix comparing fuel cells, IC engines, and LiPos for these kind of operations. One thing definitely worth mentioning is the more yellow line, the ease of use down there is. When you think of a battery, a lot of people listening to this will probably think, well, batteries are easy, but that's because you're a UAV operator and you've had to learn how to manage batteries, how to manage them safely, how to recharge them, the niggles. fuel cells are no more difficult. They're probably simpler to handle. They're more predictable. You just have to have had that initial training and that initial time to get used to operating them. So that's worth bearing in mind. They are no more complicated than batteries. It's just people are familiar with the batteries already. Like I say, I won't go into any of this in detail, but any questions I'm very happy to answer at the end. Some key target applications. So fuel cells don't make sense for every commercial UAV operation. That's definitely true, but there's a few where they really do make sense. I'm going to pick out a couple of these in front of us. Parcel delivery is an obvious one. Larger range means more serviceable customers. You can refill quicker, so you spend more time in the air. You can make your own hydrogen back at base, so refilling can be done really efficiently. And one of the main points are reiterated, the lower total cost of ownership. So for some of these parcel delivery operations to work, cost is really key. They kind of only work if you use fuel cells, because over the life of the product, they're so much more cheap than batteries. Linear inspection, another good example. A lot less downtime. You can really take advantage of the BV loss flight there. We have a couple of examples of customers really making the most of our product. To do this, Shell are using our product to inspect their ethane pipelines in the US on a BV loss waiver. Really wouldn't make sense to do that with a battery solution, but the fuel cell makes that absolutely an efficient operation there. Fraction of the cost of a manned helicopter equivalent. It's really working well for them. Another one earlier in the so in fact last year, on the cinematography front, so live sports broadcasting, we went and we filmed the Sale GP down in Plymouth. The advantage there is kind of hard to see to begin with, but if you imagine you've got a UAV that's having to come back to change a set of batteries every 10 minutes versus a fuel cell powered UAV that can stay in the air for 90 minutes. It's in the air, you've got continuous footage for the whole broadcast window. It's kind of easy to see then what the real advantages are for that in different live sport filming and other broadcasting examples. LiDAR and mapping, you're mapping larger environments, fewer stops to refuel, fewer calibration runs, again, much more efficient operations. These are the key applications where range and efficiency are really required and will really improve operations. I think it's clear how the increased flight time and reduced TCO will improve in these areas. Here's a few examples of customers that have integrated our products onto their platforms. So just for a little bit of background before I go into this, we're a component supplier. We want to replace batteries. We don't particularly want to supply UAVs. We want to apply fuel cells to multiple manufacturers and multiple service providers, just like the battery manufacturers do. And so we're trying to get this product in front of as many of these companies as we can, because we think it makes sense for them to do the integration. These guys are the professionals at UAVs. We just supply the fuel cell component. And so here are a few examples of us having done that. First one here, Harris Aerial, they're based in Florida in the US. Their H6 high drone is a 25 kilo rotary wing hex UAV, equipped with a 2.4 kilowatt fuel cell product. Recommended payloads 3 kilos, that'll give you 2.5 hours of flight. Max payload 5 kilograms, allowing 1.5 hours. You wouldn't get half an hour with the battery equivalent. So you can see why the fuel cell is good for a lot of their customers. This is being used, like I mentioned before, Shell are using it for linear inspection. This is the platform that they're using to inspect their pipelines. This UAV is on the blue UAS list in the US. Other utilities are using it in the US to inspect not only pipelines but power lines, and it's being used for border patrol in some areas. So this is a really great example of someone who's integrated our product onto their existing platform, and it's opening up new applications and new customers for them. Here's another example of a platform using our product. So I've mentioned this a little bit earlier. This is the Griffin Dynamics platform. Again, it's kind of a sub 25 kilo platform. It's 120 minutes. 7 kilo payload is 90 minutes, 120 minutes with 5 kilo payload, all off the shelf components, really standard industry stuff, typically used on a commercial UAV of this size. Propulsion system, power system redundancy. This is the unit that we've been building to demonstrate our technology, to test our technology. We've built a number of these, and we've used it in a number of real operational environments to prove that it works. And it's proved a great example of what fuel cell UAV systems can do. Another few examples that I'll just pick out. So the Zephyr Flight Lab Z1 VTOL, that is a military surveillance UAV. I kind of want to show some of these examples, not because they're the ones that are available, because they're a bit of a variety rather than just the 25 kilo multi-rotors. We also look at VTOLs and fixed wings, and the fuel cells are designed to be really compatible with those architectures as well. Unmanned aerospace, they have a gyrocopter with really good endurance, low noise signature, very high efficiency. ISS Aerospace, they have a couple of rotary wing integrations with our product, one of which is being used for oil field inspection with a kind of a best-in-class sensor, doing oil field inspection in the Middle East. These are just some examples. Like I say, we have hundreds of customers all doing similar things to these, but these are a couple of examples worth sharing for so you can see the variety of systems that the fuel cells are compatible with. If you're going to implement hydrogen fuel cells, you're going to have to be able to get hydrogen. It's kind of normally the first or second question people ask. How do I get hydrogen? Is it readily available? Well, it is. Hydrogen is available online order next day from large gas suppliers, pretty much worldwide. There are some best practices and familiarity barriers that people come up against. But once you're trained, it's easier to use, probably safer than batteries. It's certainly cleaner. You just need to know what you're doing. But it's a really quite a simple thing to get into. Hydrogen is a really quickly growing market as it's kind of used more in automotive areas and green energy storage. It's becoming much more prevalent, easy to get hold of, and lots of different refueling options are becoming available. A couple of examples of those. So it isn't that there is one solution that fits every application. It kind of depends what your frequency of refill is, how portable you need the solution to be, what the size of the fleet is. If you have a captive fleet that's back at base, or if you're dotted around multiple countries, it's kind of a different solution. But there are solutions to all these requirements out there. A couple of examples that are pictured on this slide. You can see what looks like a Pelly case hooked up to a standard Genie cylinder. So they're available next day delivery, order online. You can get them delivered to your site or site of your choice. You have the Pelly case, which is a compressor, and that compresses the hydrogen gas from bottle pressure into your flight tank. This is a portable unit. You can kind of stick this in the back of your van, take it to an operational site, or you can fill multiple cylinders back at base. Again, it depends on the operation you're specifically talking about. On the right there, you can see an electrolyzer. That's a good solution for larger outfits. So electrolysis is effectively the reverse of a fuel cell. What you can do is you can feed this electrolyzer electrical power and mains water, and then it can create hydrogen for you back at base. You can create your own hydrogen from sustainable power if you want to do that. And something like the rack, the cabinet you can see there, might fill kind of 10 to 12 cylinders, 10 to 12 flight cylinders per day. So you can kind of have something like this set up, fill your daily use of cylinders. So this is the sort of solution you might put in place if you're constantly flying and constantly wanting to use the fuel cell UAV. One thing I didn't mention here, portability is key there as well. It kind of depends how portable you want the solution to be, whether you want to be able to take the refill solution with you, or whether it's a backup base refill solution. Final slide from me, but I just wanted to mention this. So this is obviously a key part of UAV operations in general. And the fuel cells are part of that as well. It's really important. It's the regulatory aspect. So there are a number of standards in review and draft stage that are specifically aimed at fuel cells on UAVs. None of them are quite yet fully published, but they're very close. UL have an addition to their battery standard 3030, and ASTM have a committee devoted to this, as do the IEC. And as a company, Intelligent Energy and most of our competitors are very closely engaging with these certification bodies, the aviation authorities and different integrators to try and make sure we keep on top of and keep ahead of the game in kind of aligning these industry requirements to make sure the standards are suitable, make sure they're acceptable for all these different stakeholders. We don't want to end up in a position where suddenly some piece of legislation comes in and prevents people from using fuel cells on UAVs. We want to make sure that we're ahead of that game. And certainly I'm very, very open to engaging with anyone about this subject. I think it's key that we're engaging the right people, and if anyone wants to talk further about that, I'm definitely eager to do so. So yeah, quick summary then from me about fuel cells, and then eager to take some questions. But yeah, fuel cells enable previously impossible applications. Flight times do not constrain your UAV applications. There are commercial hydrogen refill solutions that are available. BV loss operations are really unlocked when you have the range that fuel cells provide. The technology is really scalable and applicable to lots of different UAV architectures. So VTOL, rotary wing, fixed wing. Refueling is quick and straightforward. And overall, you've got a much better operational efficiency when you've fully integrated hydrogen into your operation. So actually, that's it from me from a presentation point of view, but I'm eager to answer any questions anyone has. I'm going to see if I can navigate this Q&A section.
So Andy, if you like, I can ask the questions and you can respond.
Sure, yes.
To stop sharing your screen, and we can all engage a bit better with sort of face to face.
Okay.
That was a fantastic talk.
Let me do that.
And I thoroughly enjoyed learning so much about that. I know we've discussed it a little bit before, but my goodness, some of those advantages are just tremendous.
Yes, I think so.
First question I have here from Chris is, I may have missed this during the talk, but he's interested in any challenges regarding slop/mass/C of G. You might have to explain that further, Chris, possibly, or Andy's nodding intelligently.
That, yeah.
Right. Changes due to the hydrogen being used whilst flying. This is taken into account for normal fuel, but is not an issue for batteries. I was wondering how hydrogen fitted into this.
Yep, question makes sense. It's a really good question. So obviously, when you're integrating the fuel cell system, you have to be mindful of the center of gravity of the different components, the hydrogen cylinder, the hybrid batteries, and the fuel cell itself. But the thing about hydrogen is it's extremely light. So if you're putting a hydrogen cylinder on a UAV, the hydrogen cylinder itself might weigh 4 kilograms. And that is going to be enough energy for you to stay in the air with a 2.4 kilowatt unit for a couple of hours. But actually that hydrogen compressed only weighs about 250 grams. So over the flight, it barely changes the center of gravity of your unit. Because it's compressed gas, it doesn't have any slop or any momentum to worry about, because it's so light and it's a compressed gas. So actually, once you've got the center of gravity set up properly on the UAV, regarding the fuel cell system, actually during flight there is no issue. The hydrogen being used is almost a negligible effect on the center of gravity of the fuel cell system. So I hope that answers the question.
From my point of view, yes. Chris, are you happy with that? Please do follow up if there's any sort of further points to that. So you mentioned, waiting for more questions to come through, so please do ask them. You mentioned that hydrogen is available in multiple countries. Chris says, perfect answer, by the way. And thank you. You mentioned that the hydrogen is available in multiple countries. Does that mean that when you travel, you don't travel with the hydrogen intact, you source it in the next country?
That's right. Yes, okay. That almost always is the case. There are ways you can ship hydrogen dangerous goods, or you can transport it by road and rail. Most of the kit that we is rated such that you can transport it by road and rail in the US and in Europe. But typically, you would just get a bulk tank of hydrogen delivered to where you're going to be, because the large gas provision companies typically span most of the world. They can kind of deliver anywhere. So that's how you would typically approach it.
Great, that's really useful. Thank you to know. The other thing you mentioned was the USA Blue List. Do you want to, can you expand on
Yes.
what that is? It may be a term that people haven't necessarily come across. It's one I only came across recently myself.
Sure, yes. So that is, it's a tool for for the US military. It makes the US defense purchasing process a lot easier. So once you get onto that list, it's kind of, and so this is going to be a little bit, well, you see what I mean. I don't know the detail, but I'm gonna put it into some words that will make it make sense.
Puts you onto a preferred providers list,
rather than having to go through the months and months of process to for them to the end users to be able to purchase your product. They can kind of turn up with a credit card and just say, I want some of them, and they can get it. That's a really crude way of putting it.
Okay, that's great. And is that just for the military, or is that for other sort of governmental organisations?
It's all government organisations in the US.
Okay, so really useful.
Yes, yeah.
Point.
And what that means is it's been through various reliability and cybersecurity tests so that they are comfortable with it being used in governmental applications.
Mm-hmm. Great. That's fantastic. You covered off, but you got through 2/3 of the way through your presentation, and then actually you covered off one of the questions I had was,
okay,
can your system be used on fixed wing drones? Because the first part was predominantly about sort of multi-rotors. But,
absolutely.
I think
I'm happy to expand on that a tiny bit. Maybe I should have had a slide on this, might have been useful. I'll try and explain it in words. So with a rotary wing UAV, you would typically, like the chart I showed, you would size the fuel cell to be average load, so hover power, and the batteries will take the peak power. On a VTOL UAV, you would typically size it so that the batteries, and our systems are configurable in this way. You can pair the system with any size of battery you want. So you might want to pair it with larger batteries. So the batteries are providing the much higher takeoff and landing load, but the fuel cell is just providing cruise power. That's a much more optimized way of doing it. Again, you get the best of both worlds. On a fixed wing UAV, similar kind of erratic load profile as a rotary wing, but the power draw tends to be much lower. So you might be able to change the ratio slightly of the fuel cell versus hydrogen storage. So you might have a smaller fuel cell. Typically, our 800-watt fuel cell would be aimed at fixed wing UAVs, where our 2.4 kilowatt would be aimed at commercial rotary wing UAVs. But certainly our products are designed to be compatible with all those architectures, and the way that they're configurable lends itself pretty well to that.
Excellent. That's really useful. Thank you for expanding on that. Honestly, there are such huge advantages. I'm looking through my notes that I've made as we've been listening. Half the cost of batteries, 3 times the flight time saving, managing fuel cells, and savings on environmental waste, noise reduction. I mean, it's a huge list of benefits. It's fantastic.
Yes. I agree, which is why I'm taking any opportunity that I can to tell the industry about it. I think it's exciting, and hopefully people will see that. And yeah, I'm really eager to chat to more people about it and find out how specifically those things might fit into different end use applications.
Sure, I've got 2 questions here.
Sure.
One from Les. When you mentioned military surveillance, is this the Zephyr Flight Lab Z1 ZTOL? Is it just used by the US military, and do they only use it with a fuel cell?
Okay, yes. So that is primarily what the Zephyr Z1 is used for. We do have many other customers that use our products for military surveillance, and we have a number of different applications. So there isn't just the Zephyr Flight Labs solution. There are a number of different ones. In fact, I'll mention, because it's probably of interest, our latest product development was part funded by DASA in the UK. So the Defence and Securities Accelerator funded the development of one of our most recent products to make sure it was suitable for military surveillance use. And there are a number of different platforms that's targeted at. The Zephyr Z1 specifically, no, not just used by the US military. That is its target end use, but they do offer it commercially, and there are other uses for it. There is a battery version of it as well, but the advantages are, well, I've talked about the advantages of the fuel cell version. They're aligned with the Zephyr on the Zephyr platform as well.
Okay, that's great. In terms of the training for it, is that something that I'm assuming that's something that Intelligent Energy does and provides?
We can put you in touch with the right people to do it. We don't specifically provide the training, but we know who does. We all go through it here. We're very close to that side of the hydrogen market, the handling. We're obviously really proficient at that. We don't do the training, but we can point you in the right direction for the training.
And how long does that normally take? Do you know?
Yes. So
on the size of fuel cell that you're going to use.
It's more generic, actually. The fuel cells don't really take much training. What the training that we would be talking about is handling high pressure flammable gas. That's the thing you would want to be trained in, and it might be similar to how you would handle batteries. It's kind of knowing how to store things, knowing what to connect to what and what not to connect, and just kind of the typical health and safety things that you might need to take into account in your operation. It is probably more general than you might think. Okay. It's a lot of it's common sense. It might be like a couple of hours to half a day's worth of training to get that, and then the rest is practice and experience.
Well, that's very useful.
It's quite straightforward.
That's really good to know. Thank you. And we've got a comment here which is just saying, very good, looking at the hybrid architecture.
Okay. Yeah, yep. Good. Yeah, we put a lot of effort into making sure our product was compatible with all end use and all different platforms. So yeah, we put a lot of work into that, and so far it's proving to be useful to a lot of people.
That's great. If there are any more questions, please do pop them in the Q&A box. But in the meantime, I will say I'll make sure that Andy's details are sent out with this afternoon's email telling you when the Watch Again facility is up on the website, so that you can contact him further about this. We're very happy. If you forget what it was all about, very happy, please do get in touch with us here at ARPAS. It's membership at ARPAS, ARPAS.UK, and we are more than happy to direct you on to Andy and Intelligent Energy directly. That's fine.
I will reiterate, very, very eager to take any questions that might come up, and yeah, please don't hesitate to get in touch.
That's fantastic. I think that's probably then it for the moment.
Thanks for the opportunity.
Thank you very much indeed, Andy. That was a fascinating discussion.